Okay, class, let us continue with our discussion on parabola. So we're done with your parabola whose vertex is at the origin, which is at 0, 0. This time we'll consider the equation or your parabola with vertex at point hk, where the point hk could be found anywhere on the Cartesian plane. Let's look on to the definition. The general form of the equation of your parabola is of the second degree polynomial into variables that is given by ax squared plus dx plus ey plus f equal to 0, or the other equation is ay squared plus dx plus ey plus f equals 0, where the values a, d, e, f are actually real numbers, or they are constant, and the value of a is never equal to 0. Why? What do you think will happen when the value of a becomes 0? So the equation becomes a linear equation because the second degree term will be missing. So it's not a second degree term anymore. Okay? Next, the standard form of the equation of your parabola with vertex at hk is given by the two equations. The quantity x minus h square is equal to 4p equals y minus k. Or the other equation is given by the quantity y minus k squared equals 4p quantity x minus h. Take note of the coordinate hk is actually found by having the value of h here in your equation and the value of k in the other side of your equation. Now take note that h is actually always paired with x and k is always paired with y. Now 4p is the length of the latus rectum and p is actually the distance of the vertex from the focus and the directrix. So we have to take note of these two standard forms. Now let's have an example. Given that the equation is to be the quantity x minus 2 squared is equal to 4 times y minus k. So the equation actually follows the standard form, which is of this form. X minus h squared is equal to 4p quantity y minus k. So what are the information that can be obtained from this standard form? So first and foremost, the vertex is obtained by having hk, right? Therefore, from this equation, we can have our h to be 2 and k to be 1. Common error: when identifying the value of h and k, make sure that the sign or the operation here is minus. So in our case, our h is 2 and our k is positive 1. Both are positive. So when would be the time when the value of h and k becomes negative? That is when the operation here changes into plus. So if this is x plus 2, then our h should be negative 2. If this is y plus 1, then our k should be positive or negative 1. Okay, next, other than the vertex, we could actually identify the axis of symmetry. So take note that x is squared. So whenever that x is squared in our parabola with vertex at 0, 0, the axis of symmetry is actually the y-axis, right? So here, it's not the y-axis, but it should be parallel to the y-axis. So it's actually the line that passes through 2, 1. Now, what other information can be obtained? The latus rectum. Latus rectum is given by 4p right? The absolute value of 4p, and 4p is actually equal to 4. So that means the total length of the latus rectum is 4 units. Other than the latus rectum, we could identify also the focal distance. Dividing both sides of this equation by 4, you'll obtain that the value of p is actually equal to 1. Okay? Take note that the value of p here is positive 1. If the axis of symmetry is parallel to x, the vertex is at 2, 1. That would mean from the vertex, you just have to move 1 unit upward, right? Okay, so that would mean that from the value of p, you would always identify the opening of your parabola, which is upward in this case. Next. Okay, since p is greater than 0, parabola opens upward. If p is less than 0, then that would mean that the parabola opens downward. So again, that would depend on the case of the equation. If the equation here has y here, which is squared, then the axis of symmetry would be parallel to the x-axis instead of y. Now, so in that case, if p is positive, it's either be opening, it should be opening to your right, and if p is negative, it should be opening to your left. Okay? Now let's go to the graphing of the equation. So from the given, take note, before we proceed, whenever you draw a graph or the Cartesian plane, make sure to label your Cartesian plane with your x and y axis. Okay, vertex is found to be at 2, 1, so we'll try to locate vertex here. So that's 2 units to your right and 1 units upward, right? Okay. Next, other than the vertex, we have the focus. Because p is equal to 1, so that would mean you move 1 unit upward since the axis of symmetry is parallel to y. So we locate the point or the focus to be here. Okay, so drawing the line of symmetry parallel to x or to y, passing through the vertex and the focus. Okay, are we clear? Next, the directrix is actually 1 unit from the vertex, correct? So we'll draw the line 1 unit from the vertex. So we'll move 1 unit downward. So you'll have the line here, which is the directrix with equation y equals 0. So because the line passes through the y-axis at the origin, which is 0. So your equation is y equals 0. Other than this, we need to identify the focal distance, which is 4 units. Remember this, it's equal to 4p. So that would mean from the focus, you'll be moving 2 units to your right and 2 units to your left for a total of 4 units. So we simply draw actually should be a hidden line or a broken line that could be drawn perpendicular to the axis of symmetry and the y-axis, parallel to the x-axis. And then you just have to count 2 units to your right and then 2 units to your left. Okay, what else do we need to find? Okay, so probably we're ready to sketch the graph of your parabola. So parabola should pass through the end of the latus rectum and the vertex. So it's actually opening upward. So the endpoints of the latus rectum are given to be 4, positive 2, and 0, positive 2. Next. The given equation is actually in the standard form. So you might want to transform this into the general form. And how do we do that? Simply by expanding the given equation. So here, you will have to expand this square of a binomial. Here, you will have to distribute 4 to each of the terms here. So that would yield the new form where you will have to square the first term, you square the second term, and then you multiply the first and the last term here, which is -2, and then multiply it by 2 to get -4 for the middle term. Distribution, you'll have 4y minus 4. So after doing this, you just have to equate the to make the equation equal to 0, or one side of the equation to be equal to 0, simply by transforming the terms on your right to the left. So that would yield x squared minus 4x plus 4. You'll have minus 4y plus 4. And then you got to simplify this. So rearranging the terms, you'll have x squared, negative 4x, negative 4y, positive 4 plus 4 is positive 8 equals 0. Okay? So after doing this, what should be the next? Okay, actually you're done. This is now your general form of the equation of your parabola. Okay, do you have any question before I go ahead and proceed with the other examples? Let me hear from you.